Good afternoon, students. Welcome to 11th lecture of R&AC. We are in the unit 2. So in the last class, we have discussed about the concept of introduction to the vapor compression refrigeration system. So today in this class, we will discuss about the components of vapor compression refrigeration process and merits, demerits, applications, and some of the problems related to the vapor compression refrigeration process. Okay, right. So in the last class, we have discussed about the refrigeration systems are of two types. One is vapor compression refrigeration system. Other one is a vapor absorption refrigeration system. So in the vapor compression refrigeration system are generally used in the household and domestic applications. So we have also learned the temperature which is inside the fridge or refrigerator is 3 degrees centigrade. So when the temperature at deep freeze or inner freezer is minus 18 degrees centigrade, so that's why we will get faster cooling when compared to the normal cabin inside the refrigerator, right? So now we see the main components of refrigeration system. So in this refrigeration cycle, if you see the line diagram of this refrigeration cycle, we have how many components? We have 4 components to be discussed. We have majorly 4 components to be discussed. So in the first point of thing, we have a, an aluminum sheet. So we have the first one. So we have an evaporator, right? One evaporator. Next to 2 to 3 is a compressor. 3 to 4 is a condenser. 4 to 1 is a expansion device, right? So here we are having low pressure side. Whenever it is going top level, it is having high pressure side. So like this, we are having 4 devices to spend. That is specializing right. So now we'll discuss each one of this component in detail. So low pressure side is at the bottom level of this system, and high pressure side is at the other level of the system, right? So we will discuss about the evaporator concept. So what is the meaning of evaporator here? So it is going from 1 to 2. The low pressure liquid refrigerant. So refrigerant 2022. So normally in the household refrigerators, what type of refrigerant we are using? We are using Freon 22. We are using Freon 22. Low pressure liquid refrigerant in vapor in evaporator. Low pressure refrigerant, low pressure liquid refrigerant in evaporator absorbs heat and changes to the gas. So that's why we should be very careful while selection of the water, right? So whenever the low carry water is sent into the pipes, so automatically it becomes damaged. So it should be hot water in conditions. So in pipelines, there is any setup for the top. But if you see, so here itself we are storing for additional information. So the evaporator we are having in the low pressure refrigerant. The low pressure refrigerant in the evaporator absorbs the heat and changes to a gas. అంటే ఈ ఎవాపరేటర్లో ఏం జరుగుతుంది? The liquid refrigerant అనేది absorbs the heat Evaporator absorbs the heat and changes to a gaseous form. It will convert. So it is taking the liquid form and it is converting into the gaseous form in the evaporator. So that is the concept of the evaporator. Next. Next one is 2 to 3. So what happening in this 2 to 3? So in the 2 to 3, in the 2 to 3, a superheated vapor. So from evaporator energy, whenever the gases is going into the compressor, the superheated vapor enters the compressor where the pressure is raised. So ఇక్కడ మనము ఎక్స్పాన్షన్ డివైజెస్లో నుంచి రెఫ్రిజరెంట్ దీనిలోకి పంపించినప్పుడు ఎవాపరేటర్లో హీట్ని అబ్జర్వ్ చేసుకొని ఆ రెఫ్రిజరెంట్ గ్యాషియస్ ఫామ్లో కన్వర్ట్ అవుతుంది. ఇక్కడ తర్వాత ఏం జరుగుతుంది ఫ్రమ్ ద ఎవాపరేటర్ నుంచి కంప్రెసర్ మధ్యలో సో ద గ్యాషియస్ ఫామ్ the gaseous form is again sent to the compressor which is pure increased where it is the pressure is increased. So whenever the refrigerant gaseous form is going into the compressor, the pressure get raised, right? It is converted into superheated vapor. Okay, superheated vapor. So this line will be your basic, bottom line will be your lower temperature, this line will be your top temperature, right? Next. So next one, see here. So in the compressor chamber, the evaporator, so the gaseous form, the refrigerant which is converted to gaseous form and stores in the evaporator is moved to the compressor where the temperature is highly raised. Once in the compressor the material is getting raised, so automatically we have to cool down by using some of the condenser process. So from this compressor, it is going up into the condenser. So here the condenser, the high pressure superheated gas, the high pressure superheated gas is cooled in the condenser at several stages in the condenser. So ఎప్పుడైతే మనము హాట్ గ్యాస్ ఎవాపరేటర్ లో నుంచి మనము కంప్రెసర్ లోకి పంపిస్తున్నామో కంప్రెస్ అయినప్పుడు లోయర్ లోయర్ టెంపరేచర్ లోయర్ గ్యాస్ ఈస్ మంచి రేటుకి we can sell it, right? So that's why it is converted in several stages into the condenser. So what is the purpose of condenser here? The high pressure supersaturated gas is cooled at several stages in the atmosphere. Next one. Next. So once the condenser takes the pressure at several stages, next it is passing to the this expansion valve. What does this expansion valve does? The liquid passes through expansion device where it reduces the pressure and controls the flow into the evaporator. Again, the cycle process takes place. So here the liquid passes into the expansion device where the reduced pressure controls the flow of the line. Flow of the line. So this is a 4 cycles used for this vapor compression system. Next. Next, coming to the types of refrigerant. So the refrigerant గురించి థర్డ్ యూనిట్ లో డిస్కస్ చేయాలి డీటెయిల్ గా. బట్ ఫర్ దట్ బిఫోర్ దట్ I will give the minimum information about the refrigerant. A refrigerant is a chemical substance which is in the form of liquid, is used as a hot, is used as a oxygen to the refrigerator and air conditioning machines, right? So here the freons refrigerants are of various types. One may use the so process in the process, right? So if you see the refrigerant, so what type of refrigerant we are using for this type of VCR system? So a VCR system, a VCR system, VCR vapor compression refrigerant system is uses determined by the required cooling temperature. The coordinated fluorocarbon CFCs అంటే chlorinated fluorocarbons or freon simply called as a freon. So what type of refrigerants we are using? Freon R11, R12, R21, R22 and R502. So these are the different types of refrigerant we are using for this vapor compression refrigeration system. Okay now, next, vapor compression refrigeration system components what we have discussed: the compressor, right, the condenser, the expansion devices. So it were of various designs determined by what? Determined by the refrigerant, the required cooling, type of load they are using, and the maintenance what they are giving, physical space requirement, and availability of utilities. So whatever the components we are using for this vapor compression system, whatever the components we are using for the vapor compression system, so there the design changes depends upon the application. The design changes depends upon the application, depends upon the type what they are using, depends upon the type what they are using. So depends upon the type of refrigerant, the required cooling, how much cooling it is required, and the type of load, heavy load, medium load or light load, and maintenance, easy maintenance, and physical space requirements, and availability of utilities అంటే water, power, right, other things required for the refrigerator. Understood? So these are the main things required for vapor compression refrigeration system. So if anyone asks or if you get a question, what are the type of refrigerants you are using for this domestic refrigerators? So the type of refrigerants are R11, 12, 21, 22. That is freon, right? Next, coming to the advantages of VCR. So coming to the advantages, the smaller size for a given refrigeration capacity. So the requirement can be smaller, medium or larger, depends upon the refrigeration capacity. So smaller size of refrigerators can be designed based upon the capacity of the refrigerator. Next, second one, higher coefficient of performance. So we are getting good and higher coefficient of performance of this refrigerator. Next one, lower power requirements for a given capacity. So we are having low power requirements. So generally whatever the electronic devices what we are purchasing outside, so generally we see we require lower power consumption. Current ఎక్కువ కాలకుండా we have to check the electronic devices. That's why if you see the iron boxలు కానీ వాటర్ హీటర్లు కానీ ఏసీ యూనిట్లు కానీ ఇవన్నీ ఆన్ చేసినప్పుడు ఎక్కువ కరెంట్ కాలుతుంది అని మనము డిస్కస్ చేసుకున్నాం. మనకి అవి అందరికీ తెలుసు. But when you want to reduce, when you want to consume the power requirements, we use some sort of enhanced devices. So if you see the modern type of AC machines, we are having 5-star rating, 3-star rating, and enti the consumption will be less. Though 1 rupee cost is high, the consumption rate will be less. So that's why we use lower power requirements for a given capacity. Okay, next, less complexity in both the design and operation. So this type of vapor compression system, coming to the design and performance, we are having less complexity. So we don't have high complex in nature. So the design will be of normal to medium complex. So high complex nature lo undadu. That is the meaning of this point. Less complexity in both, less complexity in both the design and operation. Next, it can be used over a large temperature. So this type of VCR systems can be used for over large temperature. This can be used over large temperature range. So these are the main advantages of this vapor compression system, right? So if you see here the simple line diagram of this vapor compression single stage vapor compression system, we are having a condenser one side, we are having expansion valve one side, we are having evaporator one side, compressor one side. So some figures you can see the evaporator at the bottom, expansion valve ikkada untundi, condenser ikkada untundi, compressor orals ikkada untundi. So whatever the position of the physical products, whatever the position of the physical products, so there is no worry. Only the thing is the line diagram which meets the which. Understood? Which meets the which thing. So if you see here evaporator from the expansion valve, the liquid plus vapor is passing into the evaporator. So ఇక్కడ evaporator ఏం చేస్తుంది? In this evaporator we are having a fan. The warm air is blown from this direction and the cold air is coming outside through the evaporator. So here the evaporator, here the liquid is converted into gaseous. The liquid is converted into gaseous form, vapor form, and it is passed into the compressor. Here it compresses. Here the vapor get highly compressed and the vapor is passed into the condenser to get condensed. Later the vapor is converted again into the liquid form. From the liquid again it is passing to the expansion valve. Thereby from the expansion valve, here the liquid is converted into liquid plus vapor form. So like this the cyclic process on going in the simple SVR system. Understood? Next, so 05. So the domestic refrigerators or VCR, the application of this refrigeration for domestic purposes are mainly in the form of domestic refrigerators and home freezers. So the VCR system applications generally ekkada use chestamu. So we use the VCR systems, vapor compression system, generally for house purpose and home freezers. The main purpose of this type of refrigeration is to provide low temperature for storage and distribution of foods and drinks. అర్థమైంది కదా? 110, 210, 2.5. So this all depends upon one. So the main purpose of this type of refrigeration is to provide the lower temperature for storing and distribution of food and drinks. It represents it represents a significant portion of refrigeration industry due to the use of these units in a large number. So it has got some awareness, it has got some goodwill in the refrigeration industry due to the use of these units. And for domestic preservation, what we are doing for domestic preservation, a storage is generally short term. So during the domestic reservation is a medium type, or it may have some negative impact, right? So for domestic preservation, the storage is generally short term. The domestic refrigerators used for the purposes are usually small in sizes, ranging from 1 to 20 to half ton, right? So like this, you are having various types of refrigerators for domestic purpose, right? Domestic purpose or hotel purpose. So whenever you are keeping any small, very small firm, depends upon the nature of the firm and the type of products you are performing. You have to keep the clothes, right? Not to keep open just like this normal stitch. Next one. Coming to the requirement of the refrigerator system is coming to the refrigerant of domestic refrigerator is refrigerant of domestic refrigerant. The requirement of domestic refrigerator is the design should be very simple, automatic in action. It should be automation, and the nominal cost, initial cost should be nominal. So these are the main requirements of domestic refrigerator usage. Domestic refrigerator usage. Next, it depends upon dependable and without any necessity or expert inspection and repair. So the requirements and the applications are so dependable. It is dependable and without any necessity of expert inspections and repairs can be done. Next, no irritant and non-toxic refrigerant should be used. So the refrigerant what we are using for the refrigeration system, Freon 21, 22, 11, 12, like that. So you should not use non-toxic refrigerants and non-irritant refrigerants. Generally, methyl chloride, Freon 12, Freon 11 are used as a refrigerant, right? Methyl cyanide cyanide solution, right? Next one. On the next one. Generally, we are using Freon 12, Freon 11, and methyl chloride for this type of VCR systems. Next, the common type of domestic refrigerator have a cabinet shaped with compressor, motor, fan assembly, a condensed and a receive fitted in their basement. So these are the general parts that are used. Next, the expansion valve evaporator coils or the expansion valve evaporator coils are exposed in the storage cabinet with the piping carrying liquid refrigerant passing through the type of fluid, right? Next, the heat of the body is to be cooled. So whenever you are keeping the objects normal temperature objects in the refrigerator, the heat of the body should be cooled is carried to the evaporator coils by the means of air trapped in the cabinet. So అలా జరుగుతుంది. Whenever the objects we are placing in the refrigerator, we should not get that reflection, right? The heat of body is due to the heat of the bodies can be cooled in anticipation to right. Next, refrigeration. Refrigeration is not only provided with a double-walled cabinet packed with materials having high thermal insulation such as fiberglass, glass wool, expanded rubber, but also all round the inside floor door flap. Soft rubber seal is used in a number of which makes rubber as a airtight. So here what it is saying here, the refrigeration, the VCR refrigeration is not provided with a double walled system, right? So is even case should give next. So the refrigeration which is not provided with the double walled cabinet packed with the materials having high thermal insulation such as fiberglass, etc., are used around the inside door flap. Soft rubber seals are used to make the airtight. So these are the things what we have done, so that for tomorrow or for next week, coming week, most probably all the stuff what I say. So could be very simple and around the uh, right. Next, so we can solve one problem out of this problem. Now see here, a simple refrigerant 13134A అంటే దాని పేరేం పేరు refrigerant పేరు tetrafluoroethane. A simple refrigerant tetrafluoroethane heat pump for a space heating operates between temperature limits operates between the temperature limits 15 degrees centigrade and 50 degrees centigrade. Heat pump for space heating operates between how much temperature limits of 15 degrees and 50 degrees centigrade. The heat required to be pumped in the 100 mj per 100 mj per h. Determine the dryness fraction of the refrigerant entering the evaporator, the discharge temperature assuming the specific heat of the vapor as 0.996 kilojoules per kg Kelvin, the theoretical piston displacement of the compressor and the theoretical power of the compressor and the COP. So this is a question. The specific volume of refrigerant 134A saturated vapor at 15 degrees low 0.04185 meter cube per kg ఉంటుంది. The other relevant properties of R134A are given below. So this is a given data. So the entire question, you will get this type of problems in the main exam. So saturation temperature and the 15 degrees, 30 degrees. So 15 degrees దగ్గర pressure bar in the 4.887. 15 degrees దగ్గర 4.887. 30 degrees దగ్గర ఎంత pressure 13.18 bar. The specific enthalpy kilojoules per kg. The specific enthalpy kilojoules per kg. Liquid length ఉంటుంది. We are having 220.6. వేపర్ లోకి వచ్చేసరికి 413.6. ఇక్కడ 50 డిగ్రీ సెంటిగ్రేడ్ లో 271.9, హియర్ 430.4. నౌ స్పెసిఫిక్ ఎంట్రోపీ kilojoules per kg Kelvin, liquid లో ఎంత 1.0729, 1.7439, ఇక్కడ 1.2410, 1.7312. So this is a total given question, right? Now write the given data very clearly. So what it is given here, question చూడండి, limits are 15-30 degrees. So here, so according to the PS diagram, PV diagram, T1 T4 T2 T3 అన్నమాట. T1 T4 is equals to the temperature limits are 15 degrees అంటే T1 T4 15 degrees అంటే 15 plus 273 288. So T2 dash that is equal to T3 dash is equals to 50 degrees centigrade అంటే 50 plus 273. Now the pumped the heat Q in the 100 into 10 to the power of 3 kilojoules per hour. Next, ఇంకేం చెప్పాడు, determine the dryness fraction, the discharge of the compressor, the specific heat of vapor. ఇది the specific heat Cp vapor is equals to 0.996 kilojoules per kg. Next, V1, the theoretical piston, the theoretical power compressor, the COP, the specific heat is 134A, and the saturated vapor V1 is equal to 0.04, and HF1 is equal to 220.26, HF3 is equal to HF4 is equal to 271, H1 is equal to 413, this one 413, and H2 dash is equal to 430, SF1 is equal to 1.07, S2 S1 S2 is equal to 1.7, and SF3 is equal to 1.2, and S2 dash is equal to 1.7. So we have to draw the TS diagram and pH diagram respectively. See here the TS diagram and pH diagram. See the pH diagram. So the enthalpy, so pressure on the y-axis, enthalpy on the x-axis. So here we are having various specific heat. So here it is shown H2, H2 dash, H1. So here the 1 to 2, 2 to 3, 3 to 4, 4 to 1. So from 1 you are having H1, from 2 you are having H2, from H2 dash you are having 2 dash, right? Next, from 4 you are having H3F3, from here you are having HF3. So coming to the temperature and entropy, so T1 and the T1, so 1 to 2, T1 is 288 already given the question, T2 is equals to T2, T2 dash is equals to T2 dash, T3 is equals to 323, and T4 is equal to 288. So like this you have to draw the figure based upon the problem. Now what is to find, determine the dryness fraction of refrigerant entering the vapor. Determine the dryness fraction of a refrigerant entering the vapor. So the dryness fraction of refrigerant entering the vapor, that is the 0.4 at 0.4. See at 0.4, at 0.4 x4 is equals to H4 minus HF1 divided by H1 minus HF1. H4 minus HF1, H1 minus HF1. So H4 value, HF1 value we are having, H1 and HF1 values also we are having. So substituting those values we are getting 0.2675. Next, discharge temperature. So let T2 is the discharge temperature. So we know that the entropy at discharge, that is at 0.2. So at 0.2, S2 is equals to S2 dash plus 2.3 Cp log T2 minus T2 dash. So substituting the value S2 value, so S2 dash value 2.3 into Cp 0.996 log T2 by T2. Then log T2 by T2 dash is equals to, so if it is currently we are getting the value 0.00554. Therefore T2 by T2 dash is equal to 1.0128. Now for T2 is equals to T2 dash into 1.01. So we know that T2 dash is 223, that is equal to 54.13 degrees centigrade. Next, the theoretical piston displacement of the compressor at point 1, 2. Therefore, H2 is equals to H2 plus Cp T2 minus T2 dash. So substituting the value is 430 plus S1, and directly we are getting the value. And the mass is equals to, so the mass formula, mass is equals to Q heat by entropy. Mr is equals to Q by H2 minus HF3, that is equals to 100 into 10 to the power of 3 divided by 434.5 minus 271. So దాన్ని substitute చేస్తే value ఎంత వస్తుంది? Therefore you are converting into minutes, you are getting 10.254. Therefore the theoretical piston displacement of the compressor is equals to Mr into V1, 10.254 into 0.41, that is equal to 4.29. Next I'm going to call it theoretical power of the compressor. The work done by the compressor is equals to mg h2 minus h1, mg of h2 minus h1, that is 10.254 into h2 minus h1 value cheste we will get 214.3 kilojoules per minute. Therefore the power of the temperature is equals to the work done per joules, that is 3.57 kilojoules per second. Now what is the coefficient of performance? The coefficient of performance, here the formula h1 minus hf3 divided by h2 minus h1. So substitute చేసినప్పుడు we are getting the COP as 6.8. So we'll stop here. So the time is high, I have the class at 3 o'clock. So we'll discuss the next session in the next topics in the next session. So hope have a good day. So be at home, stay safe. So thanks for listening the class, and we are having only one student. I will take the attendance for this one. Right.
Thank you, sir.